Okay, here on, this is actually 4.2b. I forgot to change the title of this. This used to be Unit 5. This is 4.2b. Okay, so we have learned about circumcenter, which is the center of a circumscribed circle around a triangle. What we're going to learn today is called the incenter. Now, the incenter is created by the intersection of the angle bisectors. So if you notice each of these angles here on your notes, those are cut in half. So these are the angle bisectors. Now, what's cool about this is that here's my angle bisectors. These are equidistant from the sides of the triangle. So all these three pieces here are equal. My angle bisectors, again, are not what's equal. It's the fact that this point is equidistant from the sides of the triangle itself. Again, this is different than perpendicular bisector. In a perpendicular bisector, the circumcenter is equidistant from the angles. This is equidistant from the sides. So, and again, the reason why this is called incenter, I meant to actually do this kind of like I did last time, but the incenter, if you want to add this here, the incenter is the center of what we call an inscribed circle. So circumscribed went all the way around the outside of the triangle. What an inscribed circle does is it touches all three sides perfectly at one point of the triangle. So if you notice again here, what I'm going to do, if you watch the other Edpuzzle, you saw me do this, I'm going to click right here and drag my circle out. What you're going to see happen is I'm going to magically perfectly create a circle that perfectly touches all three sides of the triangle. And specifically, it touches at these 3 points, 1, 2, 3. So this is why it's called the incenter, because it is the center of the inscribed circle. So again, this is what we call inscribed. This is what we call, whoops, I messed it up. This is what we would call circumscribed, right? Outside versus the inside. Okay, so again, we're going to just practice those basic concepts. Again, over and over, guys, in this unit, things are equal. That makes our life very easy. As we said, the things that are equal here are the small pieces coming out, the distances to those sides. They're the ones at the right angles. So I'm actually going to have you guys look at example 3 first and only. We're only going to do example 3. We will do example 1 and 2 in class. So make sure you're looking at example 3. So if you notice, here is the angle bisectors. Here are my angle bisectors themselves, right? Here are the distances to the incenter. Once again, that point we would call the incenter. So these three distances are the segments that are congruent. So I'm going to erase this so you can see, but you can see your picture there. Go ahead and name those 3 segments. These 3, again, are the ones that are going to be congruent. What are their names? Well, we've got LF or FL. You've got LD. And you've got LE. These 3 are congruent. So with that knowledge then, this is pretty easy. Look at the information you have in the triangle. What would LF and LE equal then if these 3 are congruent? Well, they're going to equal LD, which is 6, right? So this is 6 and this is 6. 6 and 6. Yeah. Now, the other, again, what else is equal here? We do have those segments being equal, but because my angles are bisected, I also have equal angles, right? Bisecting an angle cuts it into 2 equal pieces. So we can also say a couple more things here that are congruent. We're just going to fill in this one. So it's angle LAB congruent to, what's the other angle? So I want you guys to try this. Find angle LAB and name the other angle that it is congruent to. Okay, well here's angle LAB. Notice that angle LAB has 1 curve, so it's congruent to this other angle over here. Now you could have named this a couple different ways actually. I'm going to go ahead and name it CAL. You actually could have used the F as well if you wanted to call it FAL. Or again, we can reverse this, LAC, LAF, those are fine. So again, these pieces are congruent, as well as we've got congruent angles here in each quarter. So in Classic, and we're going to practice this a little bit more, we're going to use the do some stuff with equations, but that's the basic intro to